Hi, my name is Amber Jackson, and I did my project this semester on M&M sequences. When I say M&M, the big M stands for the mean of the first n terms of the sequence, and the little m stands for the median of the first n terms of the sequence. Sequence being an infinite ordered set of numbers, and we're going to use a traditional definition for mean and median. So all M&M sequences start with three numbers, three initial terms. So let's consider 5, 17, and 23. To generate an M&M sequence, we're going to identify the median of these three terms, which is 17. Then we're going to find a fourth term such that the mean of the first four terms will also be 17. We're going to solve for x of 4, and we get 23, and add it to our set. We repeat this process again to find the fifth element, setting the mean of the first 5 terms equal to 20, which is the median of the first 4 terms, because the median of the first 4 terms, 17 plus 23 divided by 2. So if we repeat this over and over and over, we get the sequence. Notice that we start repeating the same number, 23, infinitely. This is called stabilization. The length of this sequence is 7 because it's the 7th term at which the terms begin to repeat, and the stable value is 23 because it is the term that repeats. So all M&M sequences, interestingly, that we've ever viewed, ever looked at, do stabilize. But we can't prove, we haven't proved yet, that this is true, that they will all definitely stabilize. So let's look at M&M sequences arbitrarily. First 3 terms, x1, x2, and x3. We're going to name the sequence generated by x1, x2, and x3 mu of x1, x2, x3. Since the order of the first 3 terms doesn't affect the rest of the sequence, we're going to assume that they're listed in ascending order. To generate a sequence, we're going to find x of n such that the median of n minus 1 is equal to the mean of n. To define stabilization, a sequence is stable at length k if the kth term is equal to is not equal to its previous term, but is equal to all of the following terms. And the stable value is x of k. Theorem 1 purpose is to find the formulas to generate all of the elements of an M&M sequence. These are the 2 formulas for x of 4, the 4th element, and the nth element. Proof part 1. To find the first formula, use the definition of mean and the construction of M&M sequences, simplify it, and we get our formula. Same for second formula for the nth term. Use the construction of M&M sequences and the definition of mean and median. We now need to understand the conditions under which we can know for sure that a sequence is actually stable. It turns out that if you have 3 medians repeated in a row, that the rest of the sequence, the stable value, will be equal to those medians. So given the formula for x sub n, we can make some substitutions since we know that m sub n minus 2 is equal to m sub n. We can substitute, solve, and it shows that x sub n is equal to m sub n. Now we can prove that x sub n plus 1 is also equal to m sub n. So now we have 2 elements in a row that are equal. From there, we know that n sub n plus 1 is equal to m sub n because the median hasn't changed. And now we have another 3 medians in a row. So this whole 3 medians, then the next term is equal, then the next 3 medians are equal, the next term is equal. It's going to keep going so the sequence is stable. Theorem 3. We're trying to now narrow down what we know will stabilize and just focus on what we don't know will stabilize. Any sequence in which any of the first 3 terms are stable, or which any of the first 3 terms are equal, will stabilize. Case 1 is when all 3 of them are equal, and it's relatively obvious, that it will always be R. The sequence will be nothing except R. The sequence is stable. Case 2 is when the first 2 are equal. identify the median to be R, solve for the fourth element, put it in our set, order it by value. We're going to find the median. The median is going to be R. Find the fifth element, order it by value, find the fifth median, and we come to see that we have 3 medians in a row and the sequence is stable. Case 3 is very similar to case 2. Find the median, find the value, find the median, find the value. And our sequence is stable because we have 3 medians in a row that are equal. So now we know that we only really need to focus on cases where none of the first three elements are equal. So now to narrow our viewing window even more, we're going to consider this sequence y sub n such that all the elements of y sub n are written as, all the elements of y sub n are alpha times the elements of x sub n plus beta, and alpha is not equal to 0. We're going to use some alternate notation since we're using 2 different sequences now so that we don't get them confused. We were using little m sub n, now we're going to use little m sub with x sub n, just so we know which is different. We're going to need to use the fact that the mean of y sub n is equal to alpha times the mean of x sub n in following x sub n plus beta in following proofs, and it is shown here that that is true. And we're also going to need to use the fact that the median of y sub n is equal to alpha times the mean of x sub n plus beta. We know that this is true because if x sub r is less than x sub q is less than x sub n, etc., then, and since y sub r, the elements of y correspond to the elements of x sub n, either y sub r is going to be less than y sub q is going to be less than x sub n, or the other way around if alpha is negative. Either way, the same 2 terms are going to be in the center, and the same 1 term is going to be in the center, so the median is going to be the same. So using lemma 1 and lemma 2, we can show that y sub n is an M&M sequence because it follows the construction of M&M sequences. Using that information, it brings us to theorem 4. We're going to let mu of x sub 1, x sub 2, x sub 3 be given where they're in ascending order. There exist constants alpha and beta such that y sub n equals alpha x sub n plus beta, and either this or this are true. These statements, 0, the first term is going to be 0, and the third term is going to be less than or equal to 2 times the second term, or the other way around. Proof, we already know that y sub n is an M&M sequence by lemma 3. To break this into 2 cases. The first case is the case when x sub 1 plus x sub 3 is less than or equal to 2x sub 2. We're going to choose an alpha to be 1 and a beta to be negative x sub 1. Since y sub n is, since that is y sub n, we can generate y sub 1 is 0, y sub 2 is x sub 2 minus x sub 1, and y sub 3 is x sub 3 minus x sub 1. And then, using our given, adding 0, we can find that our first term is 0, and our third term is less than or equal to 2y sub 2. Similarly with case 2, except we're going to let alpha equal negative 1, beta equal x sub 3, and we find the opposite is true, y sub 3 equals 0, and y sub 1 is less than or equal to y sub 2. Theorem 4 shows that since x sub n and y sub n will stabilize at the same length, we really only need to study the cases in which this is true. The first element is 0, and the third element is less than or equal to 2 times the second element. So how we apply this is that, go back to our original example sequence that's generated by 5, 17, and 23, we're going to choose a beta to be negative 5. So we can subtract 5 from each of the elements. Now we have mu of 0, 12, and 18, and those will both stabilize at the same length. Now we're going to choose an alpha to be 1/6 divide them all by 6, we get 0, 2, and 3, and that will also stabilize the same length. So we can simplify, per se, any M&M sequence this way down to a more simple M&M sequence if we define z to be x sub 2 divided by x sub 3 minus x sub 2, and x sub n to be z divided by x sub 2 times x sub n. By doing this, we have z sub 1 is 0, z sub 2 is z, and z sub 3 is z plus 1. So not only do we have the stipulations that we did before, but now by defining it this way, just to narrow it all down, we really only need to study sequences in which the first element is 0, the second element is z, and any number, real number, and the third element is only one element larger than the second term. One number is z plus 1. These are my references. Thank you. I saw that 4-minute sign and almost threw up.
I'm glad you did.
Does anybody have any questions?
What would be, if you were continuing on with this project, what would be the next thing you would work on?
The next thing I work on, they actually narrow it down a little bit further. I don't remember the exact numbers
Okay.
that they narrowed it down to, like 0.06. It's really weird. But that would be the next thing I worked on, and I would probably look into. Dang it, what was it that I was looking into?
Do you said we only need to study things that look like 0, some number, and then that number plus 1.
Yes.
Do you know what the length and stabilization is for things that look like that?
No, we don't. It depends on the.
Of course, if we know that, then we know everything, right? Yeah.
Thank you, Amber.
Mm-hmm.